Hello everyone. Today we are diving into the exciting world of LLMs and how we can fine tune them for specific tasks. We'll be working with several popular LLMs like Tiny Llama, Phi, Gamma, Quen, Mistral, and exploring techniques like quantization and LoRa to make the process more efficient. So, for the first part in fine tuning, we have Tiny Llama. So first we'll look at Tiny Llama and then we'll look at the other models. So this LLM is known for its size and efficiency, and we'll load the model, quantize it using 4-bit precision for memory, and then create a small dataset with instructions and responses. We'll then train the model by applying LoRa to create trainable parameters on top of the Tiny Llama's existing weights. And after training, we'll save the LoRa adapter, allowing us to easily load and use our fine-tuned model. Finally, we'll test the model by providing a prompt and seeing its response. So yeah, these are the training arguments and the test function, and this is the test prompt. So next, moving to 5, we have this LLM is designed for chat-like interactions, and the process is similar to Tiny Llama. Load the model, quantize it, prepare the data set, and fine-tune it with LoRa. So the key difference is here is we might be it might be due to the data structure, which would be tailored for chat interactions. So this is what we are talking about. And then we have Gamma, and as we know, Gamma is another powerful LLM, and the procedure would be the same: load, quantize, and prepare the data set and fine-tune with LoRa. We might have to adjust the LoRa configuration and training parameters based on the model's specific architecture. This is the dataset that we are manually creating, and all the functions are perform more or less the same. And next we have Quen, and here the code demonstrates this by creating a dataset of text and their summaries. After loading, quantizing, and applying LoRa, the model is trained on this summarization dataset. So this is the summarization dataset, and the script includes a testing section to show how the model generates summaries given in a text input. And next we have Mistral, and Mistral is an instruction following LLM. So we'll load the model, quantize, and then create a data set of instructions and responses. The model is trained to follow these instructions, and with which we can then test by providing new instructions and seeing its generated responses. Next we have installing Unsloth and loading model with Unsloth, all this process. And let's move to continued pre-training. Here we are installing Unsloth, and now we'll use Unsloth to load our Mistral model. Unsloth handles all the necessary configuration, making loading process much simpler. And we specify the model name, desired maximum sequence length, data type for weights, and indicate whether to use 4-bit quantization. And also we can also load the model using an environment variable to store our Hugging Face token, which allows us to access private models, and by this way we don't have to hard code it in the script. And as we have seen so far, fine-tuning LLMs is a powerful way to enhance their abilities for specific tasks, and techniques that like quantization and LoRa make this process more efficient, especially when working with larger models. And with libraries like Unsloth, it becomes even easier to leverage these techniques and explore the amazing potential of LLMs. And next we have chat templates and classification collab. And the process begins with setting up Tiny Llama for fine-tuning, where we establish different templates for handling classification tasks and conversational interactions. We implement the methods to extend the model's context window, allowing for longer conversations and more complex tasks. And the core functionality revolves around the processing multiple datasets, simultaneously also enabling the model to learn from diverse data sources. And the training loop utilizes LoRa for efficient fine-tuning, ensuring the model learns task-specific behaviors while maintaining its base capabilities. And next we have reward modeling, and this implementation combines two powerful approaches for to preference learning, ORPO, optimal reward policy optimization structures, and the learning process around reward signals, and while DPO, direct preference optimization, learns directly from preference pairs. And the training setup incorporates reward modeling, where the model learns to predict and maximize appropriate responses. And the implementation includes preference learning mechanisms, helping the model understand and generate responses aligned with user preferences. The evaluation process ensures the model maintains performance across different scenarios. And next we have mental health chatbot with Unsloth, that is continued fine tuning. And the mental health chatbot focuses on creating a responsible AI assistant for emotional support. Data processing involves careful handling of mental health conversations, ensuring appropriate responses. The training incorporates safety features and ethical guidelines throughout the process. Using the Unsloth's optimization techniques, we fine tune the model specifically for therapeutic conversations, and the implementation includes structured response templates and validation steps to ensure the model provides supportive, appropriate responses while maintaining clear boundaries. And next we have custom checkpoint continued fine tuning. And continued fine tuning builds upon existing model checkpoints, allowing for incremental improvements. The process involving loading custom checkpoints and merging them with LoRa adapters for efficient training. The implementation handles dataset management and training continuation, ensuring smooth transitions between training sessions. The checkpoint management system tracks model versions and maintains training process, while performance monitoring ensures consistent improvement throughout the training process. And next we have Unsloth Olama export and inference. So this implementation bridges the Unsloth efficient training with Olama's deployment capabilities. And the process starts with Unsloth model training, followed by conversion to GGUF format for Olama compatibility, since it supports only GGUF format. And the model file creation configures how the model behaves in the Olama environment. The export process ensures the model exports the export process ensures all model components transfer correctly to Olama platform. And the inference setup provides both chat and generation capabilities through a clean API interface, making the model accessible for real world applications. So yeah, that's it for this assignment. Thank you.